guys, Mrs. Delisin here. Welcome to another lesson of Algebra 2. Today's lesson is to identify the symbolic representation of a square root function. We'll start with f of x equals a square root of c times x minus h plus k on the outside. Of course, in order for us to fulfill this, we need to find the values of a, c, h, and k separately, and then we'll put it together. And for here, let's start with c value. If the graph travels from the vertex is where the graph started, so this is our vertex. If the graph travels left, or it's facing to the left, right, this one, and that one, the c values of those are -1. If it is facing right, just like that one or this one, our c value is a +1. When you go to a different class that is not Algebra 2 or maybe a higher than Algebra 2, the c is not always equal to 1. But for Algebra 2, we have decided that we're going to be just making it simple, and we're just going to have two values of c, which is either a +1 or a -1. Okay? Now, the value of a. The value of a, if, right here, if traveling up, then this number, so if you're traveling up, your value of a is positive. If you're traveling down, then your value of a has a sign of negative. So how do we put all of that together? So let's have an example. For each of the following square root graph, determine the symbolic representation. First, let's start with how it should look like. We have f of x equals a. We have c x minus h, and we have plus k on the outside. But of course, before we put all the numbers in, we need to figure out what is our a value, what's our c, what is our h, and what is our k. I think the easiest way to get is the c value, right? Because it's just where the graph is traveling. If it's traveling to the left, then we have a -1. If it's traveling to the right, then we have a +1. But it looks like our graph is traveling to the right. So our c is +1. Our h and k is the vertex. So if this is our vertex here, we just have to figure out the coordinate of this point. So the coordinate of this point is -4, comma, what's that? 1, 2, and 3. So we have a -4 on the h, and we have 3 on the k. And then for our a value, it's not that bad. Okay, for the a value, the first step is you go either, okay, it's option. You either go 1 unit to the right or 1 unit to the left. In this case, it's 1 box, right? From the vertex, you go 1 unit to the right or 1 unit to the left. So if this is my vertex here, because my graph is facing, right? My graph is facing right, so I'm going 1 unit to the right. And then I will count how many times you go down until you are able to touch a part of the graph. Again, you go 1 right or left, and then you go either travel up or travel down until you reach the graph. In here, it wouldn't make sense if I travel up, because I wouldn't reach the graph, right? Because the graph is down. It's traveling down. So I need to go down in order for me to reach the graph. So, and then you will count how many times you travel. That you traveled twice, 2 times, and you traveled down, so that's -2. If I traveled up, my a would have been a +2. But I traveled down, so my a is -2. And let's put that together. We have a -2. A c of a +1, x minus -4, you have a double minus going on in here, plus 3. So we're pretty much done. All you have to do is really clean it up. So a +1 here wouldn't matter, yeah? Because 1 times, there. because 1 times x right here, 1 times x would just be x. So I'll just put x. And of course, negative and a negative will give you a positive 4. And this is our final answer. So this is f of x equals negative 2, x plus 4 plus 3. Okay, moving on. Next, we have f of x equals, see, I'm doing number 3 first. Okay, I'm doing the 2 things on the left. What do I put there? Oh, so we have a c x minus h plus k. So we have a, c, h, and k. Again, our c is either a positive 1 or a negative 1. It looks like our graph is moving or traveling to the right. So our k is positive 1 again. Our h is whatever the coordinate of this point is. So that is, what is that? Negative 5, negative 4. So our h is negative 5. Our k is negative 4. And then for the a, remember, the step is you go 1 to the right or 1 to the left, depending on how many or depending on where your graph is traveling. So I'm going 1 to the right, and I'm going to count how many times I went up till I reach the graph. 1, 2, and 3. So I traveled 3 times up. So my A is going to be a positive 3. Okay? And so let's just put that together. We have positive 3. You don't really have to put the positive. And then C is a positive 1. My H is again a double negative. Oops, it's not a plus. It's going to be a minus. And then let's just clean it up. If there's something, 1 times x is x plus 5 minus 4. So our answer is going to be 3 square root of x plus 5 minus 4. Not that bad, right? Okay, moving on. We have number 2. F of x equals a x minus h plus k. So we have a, c, h, and k. Our c is either a positive 1 or negative 1, depending on which direction our graph is traveling. But it looks like it's going to the left, so my c is a negative 1. Okay? And then for my h is the coordinate of this point. That is 1, 2, 3, comma 2. So, oops, my h is 3, my k is 2. And then for my a value, I will either go 1 unit right or 1 unit left. But because my graph is traveling towards the left, I'm going 1 unit or 1 box to the left. And then I'm going to count how many times I traveled or how many units I traveled until I reached the graph. It looks like we're going to be traveling down. So our A is a negative. But it doesn't look like we went to 1 unit, yeah? It's a half of a unit, right? So half unit or 1/2. Now, Miss, is there going to be, this is so hard. What if that was a 1/3 or a 1/4? For Algebra 2, we are keeping it nice, right? I'm not gonna give you guys something that is a 4 1/3 or like 7/3, right? It's either going to be a whole number or it's going to be I think the worst that I'm going to give is like 1/2, right? So I'm not going to give anything else other than just 1/2 or 1 1/2 maybe, 2 1/2, but it's always going to be, if it's a fraction, it's going to be a 1/2. Okay, so let's put this together. We have a negative 1/2, and our C is negative 1, x, always x, our minus positive 3 plus 2. And so we have negative 1/2. It looks like we need to clean it up, right? So you see this negative right here. If we multiply that to this x, that will become a negative x, right? And then we have a negative. If I multiply that to that negative, it'll become a positive 3. So our final answer is negative 1/2 square root of negative x plus 3 plus 2. Okay? All good? Alrighty. We have here number 4, which is our last problem. We have f of x equals a parenthesis c, not parenthesis, square root of c x minus h plus k. And let's figure out our a, c, h, and k. Our c, it looks like our graph is traveling to the left. So we have a c of a negative 1. And this is going to be, what is this one? 2 comma negative 5. So our h is 2, our k is negative 5. And our a is, you're going 1 to the left, and then count how many times you have to go up till you reach the graph. So that is 1.5, right? 1 and 1/2. Or can I just say 3/2 or 1.5? Right? It's the same thing. So my a is 3/2 positive because I went up. I didn't go down. And then my c is going to be negative 1 x minus 2, positive 2, minus 5. And then let's just combine it. Make sure everything is in order. I can still distribute this negative, so that becomes negative x. And then this negative to that negative, that becomes positive 2. So our answer is going to be 3/2 square root of negative x plus 2 minus 5. And there you have it. That's how we will get the symbolic representation of a squared function given the graph. Thank you, everyone. If you have any questions, please let me know. Do not hesitate to ask if you are confused. And thank you for watching. Thank you for listening. I will see you guys on the next video. Bye.